Hi everyone! We're from Group 13. I'm Alice.
In chemistry, we sometimes need to work with exact numbers of molecules, like 1 riboflavin with 12 pectin molecules. But we can't count molecules by hand, so we use the mole to scale things into grams.
To understand stoichiometry, let's switch it to something simple like making a sandwich. Imagine the recipe says you need 2 slices of bread,
1 slice of cheese,
and the product is the sandwich. The reactants are cheese and bread.
However, if you have only 2 bread slices and 1 cheese, you can only make 1 sandwich. But if 10 slices of bread and 1 slice of cheese becomes the limiting reactant, so you can still only make 1 sandwich. Stoichiometry works in a way that not only works the same way in chemistry, just with molecules instead of 2.
A mole is a chemist's dozen, but instead of 12 items, 1 mole contains of 6.022 times 10 to the power 23. This huge number helps us convert between microscopic atoms and measurable amounts.
Okay, to convert between grams and moles, we divide the mass by the molecular mass. For example, 12 grams of carbon is equal to 1 mole. What if we need 0.254 moles of iron trichloride? We can multiply by its molecular mass, that is 162.20, and then we can get 41.2 grams of iron trichloride.
How to find percentage composition based on formula. Today's example will be N2O5. The ratio of moles in N and O are 2 and 5. To find the mass, we have to multiply the moles with its atomic mass. For finding the mass of N, we will need 2 moles times 14 grams per mole, which will be 28 grams. For the mass of O, we will need 5 moles times 16 grams per mole, which will be 80 grams. Making the total mass 28 plus 80 grams, making it 108 grams. To find the percentage, we will need to divide its mass with its total mass times 100%. N's percentage will be 28 divided by 108 times 100%, which will be 25.94%. And for O's percentage, we will need 80 grams divided by 108 times 100%, which will make it 74.06%.
To first find the atoms, we find the moles first. So in this example, we have 0.65 grams of tungsten. To find the moles, we need to follow this equation. N is equal to M R is for the molecular mass in tungsten. So in this case, N is equal to 0.635 grams over 1.838 molecular mass, which is, well, the molecular mass of tungsten, which will result in, sorry guys, which is equal to 127 over 36, well, this number. But we're not done yet, so now we need to find the atoms. Then we multiply that number, 127, 36760, times Avogadro's number, which is 6.022 times 10 to the power 23, which results in is equal to 2.08 times 10 to the power 21. This is the number of atoms in 0.635 grams of tungsten.
So with this example, there is 2.57 grams of sample and it contains 1.17 grams of tin. So first we need to find the moles of tin, which is 1.17 divided by the MR, which is 118.7. This gives us 1.1 moles. So we need to find the chlorine. We basically just need to subtract 2.57 by 1.17, which is 1.4 grams. After getting the mass of chlorine, which is 1.4 grams, we just need to put it in the formula. Mass over MR, 35.5, and it gives us 0.04 moles. So we have 0.4 moles and 0.01 moles. So now to make the empirical formula, Sn